Hi everyone, how are you doing? We'll have to wait for another 2-3 minutes. My iPad got completely discharged. Hi Pawan, hello Chinmay. Yeah, my iPad got completely discharged, so I'm just charging it a bit. Give me like 2-3 minutes. Waiting for 10 minutes. It's only 4:08. All right. So I think we should be good to go in another 2 minutes or so. Okay. Anyhow, so first of all, I don't know how this got completely discharged. Okay. So I'm still charging. It's still not switching on. So we just wait for a bit. All right. So today we'll be talking about relative motion in any case. So last time we started our discussion on relative motion, and today we'll be taking that forward from there. All right. Yep. Still waiting for this to switch on. Okay. So maybe if you can give me 1 minute or so, let me try and charge it with a cable directly instead of the laptop. Maybe that'll be faster. All right. Hmm. I didn't realize this. All right, no problem. Uh, I've left it for charge, and let's hope within 2 minutes it should be ready to go. All right. So first of all, let's talk about what we discussed in the last class. So last class we were talking about relative motion, and we realized that all the motions in general by default are always described with respect to the ground. All right, and sometimes we need to describe motion in the reference frame of a moving person. All right, that is all what relative motion is, and we had also discussed the equations of that. All right, so yeah, so we realize that if you have to find something in the reference frame of any moving object, let's say b. So if b is moving with a velocity vector of b vector and is moving with an acceleration vector of a vector, and he has a position vector of rb vector. So what you need to do is in its reference frame, when you're looking at anything, and if you know their velocities, their accelerations, and their positions in the ground frame, all you need to do is yes. Give me 2 minutes, it'll be fine in 2 minutes. Don't worry. So then we realize that the relative the all the coordinates with respect to another guy can be expressed by subtracting the coordinates of this person. All right. So when you're finding the position vectors of, let's say, a with respect to b, then that will be position vector of a minus position vector of b. Similarly, the velocity of a with respect to b would be velocity of a minus velocity of b, and the same goes with acceleration. We also realize that if we talk about b from the reference frame of b, so how does b see himself? All right, so how does he see? So we realize that everything for him becomes zero because everything is position vector is rb minus rb. So he sees his position vector as zero, which is absolutely all right because he himself will always be at the origin of things. All right. Similarly, the velocity of b with respect to b would be vp vector minus vb vector, so which will be zero, which is again all right since he sees himself to be at the origin and he continues to see himself at the origin itself. So then he will obviously believe that his velocity is zero, and the velocity will always remain zero. That is why he will see his acceleration also to be zero. All right. So those are the things that we realized in our last class discussion, and we also realized that the motion by different observers was being observed differently. So we took up the case where a moving train is there and a person inside a moving train is throwing the ball up horizontally. The observer inside the train observes the motion of the ball as vertical 1D motion, and any observer which is outside the train will see the same motion as a 2D parabolic motion. Alright, and the velocity of the ball as seen by the observer on the ground frame would be the velocity given by the person in the train plus the velocity of the person in the train. All right. And why? We realize that when somebody is holding a ball and they are moving, the ball already has a velocity which is equal to their velocity, the velocity of the person who is holding it. All right. So if he gives it an additional velocity with respect to him, then the ground frame velocities would be the sum of these two velocities. All right. So why don't I go and check if finally my iPad got switched on? So yes, Chinmay, tell me, why don't I listen to you first? All right. So yes, Chinmay, tell me. Let's talk about your doubt first, and then we can get started. Tell me, Chinmay. Okay, I'm waiting for your doubt, Chinmay. Uh, Still waiting for your doubt, Chinmay. Okay, so what is uh okay, what is what system? Okay, I am not sure of that myself. I'm not sure what septesimal system is. No, I have absolutely no idea. Are you sure you wrote the term correctly? Are you sure you wrote the term correctly? Okay. Yes, for education. Why not? Please solve my question also. All right. So yeah. That would be very easy. All right. So centesimal. Okay. Centesimal system. I seriously don't know what exactly is that referring to. Maybe it's a measurement system or something. I'm not too sure. Why don't you Google it? I'm sure you'll find it. Okay. So just wait for a minute. All right. Let's see if this works now. Okay. All right. So we have our display. Great. Okay. Just give me one more second. Okay. So finally we are good to start. Okay. So this is lecture 9 though. I think. Yeah. So before we start our discussion for relative motion, let me introduce myself one more time. So for those of you who don't know me, my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for IIT JEE. And I've done all my teaching in the offline setup, all right, and I've been associated with some of the topmost institutes in India for IIT JEE coaching. I myself was JEE rank 447, and I've already coached many students to top ranks. All right. Next, moving forward, let's also talk a bit about the Unacademy subscription. So your Unacademy subscriptions come with benefit like live classes. You get to interact with your educators. So as I said, I have done all my teaching in the offline setup. So I was also a little skeptical, when I started teaching online. So I didn't know how effective the online teaching system would be, because obviously the way I've been teaching has been having my students right in front of me, having a discussion with them, looking at them, and they could see me. So, of course, I did not know if the online system could be that effective. All right, but yes, the Unacademy is when I have taken classes on the Unacademy platform, and here when I'm taking them on YouTube, the experience is pretty similar, and there is not much difference between the teaching and my delivery of knowledge to students, my interaction with the students, which was there in the offline setup. It's very similar. So that's a wonderful thing. That is the experience that you get with your Unacademy subscription. Then you have live polls and leaderboards, which keep the classroom very interactive. So you're not feeling like you're just sitting and just watching something online. You are a part of it, part of the class, part of all the discussions that are happening. Then of course you have live test series and analysis, and on top of everything else, you have live doubt clearing sessions. Very important, because I see nowadays that a lot of students, because they can't go to their teachers, so they are very confused about how to get their doubts sorted. All right, so I keep getting a lot of messages about the clearing things. All right, however, there is a very special feature that the Unacademy courses have. So every course on Unacademy has a compulsory feature that it will have a doubt class after every 3 teaching sessions. All right. So, that will always take care of your doubts, and you won't be left confused, wondering how to get my doubts cleared. And on top of all these benefits, you're getting access to India's best educators with your Unacademy subscription. So, Unacademy is bringing all the top teachers of India on a single platform for you, so that you can easily go and study with any of these top teachers. All right. Next, so how do you get this subscription? It's very easy. You install the Unacademy app. Once you have done that, you go to the plus section, then you select your goal as IIT JEE, and you click on get subscription. All right. Now, when you're getting your subscriptions, you will also realize one thing, that the pricing of these subscriptions is very modest and affordable. And it's a wonderful thing that the pricing is kept to be so affordable for all students, so that no student, feels the pressure or burden of the fee, and can have access to such quality education, quality content, and top educators. All right. So trust me, I've taught for a long time in offline setups, and the kind of fees that you guys pay there is huge, and this fees is nothing compared to that. I know some of my students used to pay more than this for their tuitions. I know people who are paying more than this per month for their class 9 tuitions, class 8 tuitions. So getting your JEE prep done at these prices, I think it's a great thing. It's a great opportunity for you all. And okay. We will talk about that, Chinmay. So I personally think that at these prices, the Unacademy subscription is a must-have. The benefits are huge, and the pricing is nothing compared to the benefits that you have. Now, next, as I said, this is already a steal. Okay, at these prices, I mean, this is very affordable. This is very reasonable, and this will become more affordable if you use my code to get your subscriptions. My code is RDLife. So if you want to enroll in my courses, if you want access to India's top educators, if you want them to coach you for your IIT JEE journey, then you can use this code RDLive, get your subscriptions, and this will give you an additional 10% off as well. All right. Now, those of you who are following us on the JEE English channel, you can connect with us using the link shown above. So connect with us on the Telegram app, so that you're not missing out any notifications of any sessions and lectures happening on the JEE English channel. So now, without any delay, which has already been some, why don't we move forward and start our discussion with the relative motion? All right, and as Chinmay was saying that, okay, so in problems in general physics, page 22, he is unable to solve 2 problems. Okay, so Chinmay, what we're going to do is, let's finish this session and then maybe I can discuss those. And first of all, you shouldn't be starting with Erudo, by the way. Okay, have you already done your HC Verma? I uh, I think that's the book that I would recommend anybody to start their practice with. Okay, so start from slightly basic problems, and H.C. Verma has got a wonderful. I mean, the thing that I love about that book is that the way the problems are structured are very nice. Yes, so that is the problem. So in H.C. Verma, what they do is what Mr. Verma has done is that he starts with very basic problems, then slowly, the level of the problem increases as you move ahead, and every problem has been broken down into small parts, so that gives you a more chance to think about it. It also allows you to learn solving techniques, because that is how you will solve complicated problems. You always break them down into small problems. So I would advise that you first solve your HC Verma. That'll give you a fair bit of idea about your problem solving strategies and a better understanding of the concepts, and then and only then you can move to this book. Okay, so don't try this without having solved your HC Verma. Yes, HC Verma is a wonderful book. It is, I think it's a building block towards developing thinking of problem solving. Trust me, that was the book that I would always solve first. uh, okay, that your question was pretty straightforward, by the way, for education, and maybe we will take it up later. And I told you, it's the solution is also very simple. Okay, why don't I tell you right here? Okay, so for education had this problem. He did not know how to integrate sine of 2x. All right, so I know all you guys are class 11 people, so you are still not very comfortable with integration and differentiation. So I will show you this for education, but then I would advise you to watch my video on basic calculus. I think I have discussed these things. So the point that so it was integral of sine 2x dx. All right, I think this was it for education, if I'm not wrong. So all you need to do is you need to substitute. Yes, do that, Chinmay. It's a must solve book. All right. So you assume that let some u equals 2x. Now, if you differentiate this, what is du over dx? Du over dx becomes 2. All right. So next from here you can say that dx equals du over 2. Now all you need to do is start substituting these values. You substitute 2x, instead of 2x you substitute u, and instead of dx you will substitute this value. So when you do that, what you have? You have sine of u du over 2. Alright, now you know 2 is a constant, you can take that out of the integration, so this becomes 1 by 2 integral of sine u du. Now you know the integration of sine u du. Integration of sine u du is nothing but, so this becomes 1 by 2 cos of 2u with a minus sign times and plus c. Okay, sorry, it was only u. Okay, so that is your answer. Now you substitute the value of u as 2x again. So the integral of sine 2x dx you will get as minus 1 by 2 cos of 2x plus c. Alright, so that is your answer. This is a problem that for education had sent me. Alright, he was having trouble with integrating sine 2x. Alright, for education, did you follow this? This is very simple, and that is how you solve most of the integration problems, by substitutions. Okay, no problem. So if you've noted this down, I will rub it. So please note it down, or maybe take a screenshot very quick so that I can rub this. Okay, please do that quickly. Okay, I hope you have done it, because I'm going to rub it now. Alright, great. Okay, then let's get back to today's discussion. So the first kind of very commonly asked problems in relative motion is the river boat problem. So what happens in this kind of problem? You are given that a river is flowing with some velocity, and a boat is trying to get across the river. All right, boat or swimmer. So you can have river boat or river swimmer problems. It's one and the same thing. All right, so boat or a swimmer is trying to swim a certain way in the river, and how does he end up moving? All right, so that is what is asked. So we had talked about this, yeah, yesterday also. All right, so what is the velocity of boat or river with respect to water, and what is the velocity of boat or river with respect to ground? We talked about this in the last class. So let's see how to do this. So mathematical approach of solving this is that you do nothing. You find the velocity components with respect to ground in the two dimensions. So what two directions? You break all the velocities in the direction which is perpendicular to the river flow and along the river flow. All right. So those are the two directions in which you will be considering all your velocities. Once you have done that, then it's very, very easy. Do your analysis in the y direction and in the x direction. All right. So in this example, so here I've taken VB. VB is the velocity of boat with respect to the river or velocity of the boat in still water. Okay, which means had water been still, boat would have gone this way, which means the boat is trying to go this way. All right, so the boat is trying to go this way, but the river is flowing again. So where will the boat end up going? So let's see. So I can resolve this velocity of boat into two components. This component would be VB cos theta. All right, and how about this component? This component would be VB sine theta. All right. So now let's see the velocity of the boat with respect to the ground. So velocity of boat with respect to ground, that would be, I know, velocity of boat with respect to river, which is VB. Okay, so this is the velocity of boat with respect to river. All right, so this is VB with respect to r vector, by the way. So this plus velocity of river vector. So I hope you remember this relation. All right, we have done nothing but use the equations that we studied the last time. Last time we studied that VB with respect to R would be VB minus VR. If I take VR on the other side, I will get VB equals VB with respect to R plus VR. All right. So please remember this. This is all that I'm going to do. I know the components, so I can simply add the components. So this I can write as, let's see, VB cos theta j cap and minus VB sin theta I cap. All right, plus the velocity of river is VR I cap. So when I solve this, what am I getting? I am getting that the velocity of boat in the y direction is VB cos theta, and velocity of the boat in the x direction is VR minus VB cos theta. All right, I hope you guys can see that. Once I have these velocities, now there is nothing much left. Now I will solve the problem by analyzing the motions in the y and the x directions. All right, both the motions are constant velocity motions, so should not be very difficult to understand. So first of all, if I have to find the time taken to cross the river, all right, so we know that since when the boat crosses the river, the y displacement would be w, where w is the width of the river. This would be given to you. So if you wanted to find the time in which the river, the boat will reach the other point, let's say it ends up going like this. So whenever it reaches the other point, I know what is the displacement in y. The displacement in y would be w, which is the width of the river. I know the velocity of y. Velocity of y is VB cos theta. So time would be simply w over VB cos theta. All right. Then we talk about the drift along the river flow. So this distance from the opposite point is called the drift along the river flow. All right. This is called drift. Right from the opposite point, the horizontal distance that the boat ends up traveling. So what will be the drift? Drift would be nothing, but it is the distance traveled in x direction. So we already know the time. Now we also know the x velocity. So the drift would be the x velocity times the time. All right. So I hope there is no problem there. Now we can consider a couple of special cases. So one special case is that if you want to cross the river in minimum time, so that is How should you be showing that for that case? So that is very simple. You realize T was W over VB cos theta. Now, if you want your time to be minimum, then you want your cos theta to be maximum. So for this, the condition would become theta equals 0. And when theta is 0, the cos would become 1 and the time, minimum time to cross the river would be this. Alright, simply, okay, this would be W over VB. This would be the minimum time required to cross the river. Alright. So, how does this flow? This angle will become 0. The boat will try to swim in this direction, by the way. This is how boat will try to swim. Boat will try to move. But boat will actually end up moving here. But however, this will still be the minimum time in which the boat will be able to cross the river. Alright. So please note that. It is trying to move perpendicular to the river, but it won't end up moving perpendicular to the river. So to minimize the time, it would try to move perpendicular to the river. Please remember this. And in this case, what will be the drift? So what will be the drift? So the entire boat's velocity is in the y direction. The only velocity in the x direction would be the velocity of the river. I already know the time. So the drift in such a case would be velocity of river times time, which is W over VB. Alright, so in this case, this will be the drift, which is this distance. Alright, this distance would be VR, which is the velocity of the river, which will be the net x velocity of the boat also, into the time taken, which was W over VB. Okay. Next, if you want to cross the river with zero drift, then what is the condition? The x velocity should be 0. Alright, it was the x velocity which was causing the drift. If this x velocity becomes 0, then my drift would become 0. So putting this 0, I get the condition that VR equals VB sine theta. So that is the condition under which the drift of the boat would become 0. Alright. Now please note that this is only possible if VB is greater than VR. Why? Because you know that sine theta is equal to VR from over VB from this above expression, and this can only be less than equal to 1. Okay. So it is only possible to cross the river with zero drift as long as the velocity of boat is greater than the velocity of river. Alright, and here theta is going to tell you at which angle you should be moving. Alright, so if the boat tries to move at an angle theta such that theta is sine inverse VR over VB, then the net velocity, in this case, the net velocity or the ground frame velocity of the boat becomes like this only. So the boat tries to move in this direction, by the way. Boat tries to move in this direction, but the velocity of river, when added to this, will give you such a resultant. So that is how your triangle would look like. Alright, so velocity of boat in this direction at some theta. Then you add the velocity vector of river to find the net velocity. This is the resultant velocity. It should be along this line. If you have a resultant velocity along this line, then you will directly reach the point opposite and there will be no drift. Alright, so I hope all you guys are clear about the discussion so far. If you have any doubts, please let me know. Is the discussion so far clear? Are you clear about the discussion so far? Please let me know in the chat. If there is any point you would like me to repeat, then I will take that up again. So Chinmay. Okay. So Chinmay just says sir. So Chinmay, what is sir supposed to mean? Please write clear or this is not clear. Okay, great. So now why don't you try a practice problem? So which will help you get familiar with the equation. So this is a very straightforward problem, very simple, the most simple kinds of this category. Okay, so here you've been told the width of a river is 30 meters. The river is flowing with a velocity of 5 meters per second at an angle 37 degree. Okay, river velocity is at an angle 37 from the direction of the current. Okay, there is something missing. The river velocity is here, and let's just take up a number. Okay, let's just add. Boat is trying to swim. So boat is trying to move with 10 meter per second. So let's assume that number at 37 degrees from the direction of river current. Okay, so that was missing. I've added that. Okay, so please note this, that you have a boat which is trying to move with a with a speed of 10 meter per second at an angle 37 degree with the direction of river current. All right. So let me just draw a diagram also. So the situation is something like this. So you have a river here, and the river is flowing with some velocity. So velocity of river is 5. Now a boat is trying to swim at an angle 37 degrees with the current flow. So this is the velocity of boat with respect to river. This is the direction, and it is equal to 10 meter per second. All right. Now you have to find the time taken to cross the river and drift of the boatman when he reaches the other end of the shore. Okay. All right, Chandrasekhar. Thank you for that. All right. So were you attending it live, or did you watch it later? All right. So why don't you guys try this problem? Let's see. Let's see. Let's solve some problems. Let's get familiar with our equations. All right. Okay. I'm glad it helped you. And as I had said in the last class, I don't know, I had clicked some button because of which I was not getting any chat messages, and that is why I did not reply to any of those. At end of session, can you clear my doubt that yesterday I had sent you that suggestion, please? Uh, okay. So Pawan has already given all the answers. So, Chinmay, why don't you try this right now, and maybe later? I have another session planned after this from 6. Okay, so I don't think I will be able to take up your doubts right away, but maybe I'll reach out to you later. Okay, maybe at night. I'll reach out to you at a later hour when I'm free, and I will answer your doubts. Okay. So why don't you guys try this problem till then? So Pawan has already given me the answers. All right, so let's try and see. Okay, so you know the velocity of river is 5. All right, so velocity of boat. Let's use some other color for that. Okay, so velocity of boat with respect to river is 10, and it is at an angle of 37 degrees with the river flow. So this is the direction of river flow, by the way. All right. So let's see what the components are. So it has a component along the flow of the river, which would be 10 cos 37. So 10 cos 37. This is 10 cos 37. I hope everybody knows what cos 37 is. Cos 37 is 4 by 5. So 4 by 5 would become 8. Okay, and the vertical component would be, okay, please note, do not blindly use the formula that I've told before, because you remember there the theta was taken the angle from the this side, and here the theta has been given to you from here. All right, so please remember, either what you can do is, if you are using those formula which I just mentioned, then you take this angle and you write it in negative. All right, you write that angle as minus 53. Why? Because I've taken positive on this side. So on this side you will have to take negative. Then you can apply the formula directly. Otherwise, you stick to the basics. You divide your velocities into components. All right. So this component would be 10 sine 57 10 sine 37, and sine of 37 is 3 over 5. So, alright, so this would be 3 over 5, so that is 6. Alright, so now I know what is the y velocity of the boat and what is the x velocity of the boat. So, y velocity of boat was 6 meter per second. Okay, so this is my y and this is my x. Alright. Similarly, x velocity of boat is nothing but this 8 plus 5, so 13. Alright. Yes, Pawan immediately corrected as answer. So width of the river was 30. So river width was 30. So the time taken would be width over Vy or y velocity. So that is 30 over 6. So that is 5 seconds. And yes, the drift, I know, drift is x velocity into time. So time is 5, x velocity is 13, so that will be 65. Alright, so those are my two answers. Alright. Okay. So here I have one more problem. Okay, you want a direct formula based problem. See, I'm just showing you a couple of problems here. Then you can practice some problems on your own. Okay. We don't have enough time to keep practicing here. Alright. I hope you saw this. You saw how we are managing this. Okay, so you see this, then you try some problems on your own from books like H.C. Verma. No? You will need a lot more practice than just 2 questions, Chinmay. So you need to do that on your own. You see, I am discussing 2 problems here. You see how I am going about those problems and then practice on your own. Alright. Okay, so let's try another problem. Okay, so though this is not a river boat problem, but it is exactly the same, by the way. This is an airplane in wind problem. So here again, same thing would happen. The airplane would try to flow in the one direction, the wind would drift it. Or again, just like a river was drifting the boat. Similarly, a wind would drift an aeroplane, and the net velocity of the aeroplane with respect to ground would be the velocity of aeroplane with respect to wind plus the velocity of wind. So it's just different name, same concept. Alright, so let's try this. So this problem says an aeroplane has to go from point A to B. Alright, so this is 500, which is 500 kilometer away due 30 degree east of north. Okay, so I hope you know your directions. Okay, you should know your directions. What is 30 degree east of north? So, okay, let's see. Let's just make 4 directions first. So let this be north, let this be south, let this be west, and let this be east. Now, if you're told that something is 30 degrees east of north, okay, so what does this mean? 30 degrees east of north. So first you go in the north direction, then you turn 30 degrees towards east. Okay, so please remember this. That is how you judge your directions. So this is the direction that they are talking about. This angle should be 30 degrees. You are turning 30 degrees towards east from north. Okay, if it was 30 degrees north of east, how about 30 degrees north of east? 30 degrees north of east, that would have been this. You would have gone towards east and then you would have turned 30 degrees towards north. So this is 30 degrees north of east. And this is east of north. Alright, so I hope you realize the difference. Alright, one is east of north, another is north of east. So that is how you judge your directions. 33.8 degrees, I don't know. I don't remember. I will have to see. Okay. So if that is your problem, so a plane has to go from point A to B, which has a distance of 500 kilometers and is due 30 degrees north or east of north. Okay, with the wind blowing in the north direction at 20 meter per second. The steering speed of the plane is 150 meter per second. I don't know, Chinmay. I don't remember the answer right now. I will have to check. Okay, we will solve and then I'll have to check. Okay, maybe this guy. All right. So you to find the direction in which the pilot should head the plane to reach at B. Also find the time taken by the plane to complete its journey. All right. So what is happening is that you want to reach from A to B. So let's mark those points. Okay. So let's say this is my point A where I'm trying to start from, and this is my point B where I want to reach. You've been told that the distance between A and B is 500 meters, I think. Kilometers. Okay. So please remember this is 5,000 meters because this has been given in kilometers. So always remember to check your uh, answers, check your measurements units. Okay. Yes, that sounds about correct. Upon sign. Okay. Into sign. 150 into. Oh, okay. Yeah. That is fine. That is fine. Absolutely. That is correct. That is correct. So you have wind blowing in this direction. So Chinmay seems to be getting a hang of this. Very good. So this is the direction of wind. So this is velocity of wind, and that is 20 meter per second. And I have to find the velocity of plane, and let's assume that plane is in some direction like this. All right, this is the velocity of plane, and it is trying to fly at an angle some theta with this line AB. Okay, and this I know is 150 meter per second. So yes, Chinmay has got this right. So the trick is that you take your y and x as this. Okay, so you take this as y, you take this as x. All right, now you know that if you want to reach from A to B, then all your velocity should be along x only, which means your y velocity should be 0, and which means, all right. So now I can easily write for resultant velocity. For resultant velocity to be along line AB, what you need to do is you can break both these velocities into two components. Okay, so let's do that. So I can have this component of this and I can have this component of this. Similarly, for the other one, I can have this component of the plane velocity and this component of the plane velocity. If these two velocities get cancelled, then the net velocity of the plane would be in the direction AB and it will end up moving in the AB direction. That is all I needed to do. Alright, so this is just like minimizing your drift. You want to make your drift as 0. Okay. So yes, Chinmay has got this right. So VW sine 30 should be equal to VP sine theta. So that is what I can write next. So for resultant velocity to be along AB, I know VW sine 30 should be equal to V plane sine theta. Therefore, sine theta would be 20 over 150 into 1 over 2. So that is 1 by 50, which is absolutely fine. I think Chinmay has solved this, correct? Now, when you were asked to calculate the time, what do you do for time? Then you calculate what is the net velocity along the line AB. What will be the net velocity along the line AB? It will be the sum of these two components. Alright. So I can write from here theta equals sine inverse of 1 over 50. and here you have the direction of the plane. Alright, now for time I need to find the velocity along AB. Okay, so for time we find velocity along AB. So in the direction of AB, what is the velocity? In the direction perpendicular to AB, it will become 0, and in the direction of AB, it will be 20 cos 30 plus 150 cos theta. Alright, so this will be velocity along AB, or this will be the velocity of plane with respect to ground, the final velocity of plane with respect to ground. Alright, so you already know sine of theta. You can calculate cos of theta, root of 1 minus sine square theta. Alright, once you know this, time t would be the distance, which was 5000 over Vp. So just remember to convert your distance into meters, because it hasn't given to you in kilometers. Alright, and otherwise you will be fine. So that is how you solve this. This is a very easy standard type problem. Okay, and okay, so this maybe some other time. Then another category of problems that you have in relative motion is rain-man problems. So in these problems, the velocity of rain and a man are given to you, and the aim is to find the relative velocity of rain with respect to man. Alright, so you are told, okay, so rain may be falling like this at some theta with the vertical. This is velocity of rain vector. Alright, and a man is moving like this, velocity of man vector. So how will the man see the velocity of rain? So all you need to do is just again write this in two components and then solve this. So we can write the velocity of rain vector as Vr cos theta, and I can add a minus j cap here, and minus Vr sin theta I cap. Alright. Similarly, how about the velocity of man vector? Velocity of man vector can be written as Vm I cap. And now I know what I needed to calculate. I needed to calculate what is the velocity of the rain that is seen by man. So I know this is nothing but Vr vector minus Vm vector. Alright, so what will that give me? That will give me minus times, I have Vr sin theta plus Vm I cap, and I have plus Vr cos theta j cap. So that is how I will find the velocity of rain with respect to man. And now, what all are the things that are asked of us? So I am asked, what is the direction of rain with respect to man? So that is very simple. So you first find the velocity of rain with respect to man, and let's see how we do that. We have this velocity, which is Vr cos theta, which will remain unchanged. Now this is in the reference frame of the man. So everything which is written in black, this is in ground frame. Alright. Now everything as blue is being made in the man's frame. So he will have this kind of velocity, which would be Vr sin theta plus Vm. And here the man would obviously be stationary now. Alright. So what would be the direction of rain now? I can make a parallelogram, and this is the velocity of rain with respect to man. Now if I needed to calculate the angle that is being made with the vertical, so alpha, so I can write from here that angle with vertical of Vr with respect to man. How will that be? You will see this triangle, you will realize tan theta is nothing but a perpendicular upon base. So tan theta would be Vr sin theta plus Vm over Vr cos theta. Alright, that is how you do it. All you need to do is find the velocity vector of the rain with respect to man, and then you can tell the magnitude, how much velocity the man is seeing, The magnitude would be very, very simple. This square plus this square's root. Okay. So square of your x velocity, square of your y velocity, and root of that. That is the resultant. All right. Similarly, the angle. Okay. So this is alpha. The angle of rain. The rain appears to be falling at an angle alpha to the man, which is given like this. All right. So why don't we practice one problem again? So you've been told a man is walking with 3 meters due east. The rain is falling vertically downwards at with a speed 4. To find the direction in which the man should hold his umbrella so that the rain does not wet him. Okay. So solve this. All right. Let's get this done quickly. This is a simple problem. Okay. All right. Please write trying in the chat so that I know you guys are trying. Okay. All right. I'm still waiting for somebody to write trying. Chinmay. Okay, 37 degrees. With the horizontal, with the vertical, you need to specify that, Pawan. You need to always specify is your angle with the vertical or with the horizontal. Okay. That seems about correct though. Yeah, it should be 37. Just that, please tell, is this angle with the horizontal or with the vertical? Because it'll be either 37 or 53 then. Okay. Okay, so why don't I just show it? This is very, very simple. And half the times I don't even like writing equations. So please remember, in such questions, sometimes it's just better to make vector diagrams. Okay. So man is walking. Okay, man is walking with. So you don't even need to write the. Just make vector diagrams. So this is the velocity vector of man. All right. What is the velocity vector of rain? It is vertical with this. Okay. So velocity vector of rain is this. So I know what will be the velocity vector of rain with respect to man. That would be velocity vector of rain minus velocity vector of man. So I need to draw this. This is 4 meter per second. And then minus of this. Okay, so from here I can draw minus of Vman. So this is Vr vector. This is minus Vm vector. Okay, this is 3. When I add them, this would be the velocity of rain with respect to man vector. And clearly I can see from this triangle that this would be 5 and this angle with the vertical would be tan inverse of 3 over 4, which is 37. Okay. So I don't have to write equations all the time. So please remember that you can make vector diagrams, triangles only, and solve your problems easily. So I know tan theta equals 3 over 4, so theta equals 37. So that is my answer, yes, with the vertical. I can see here it is the angle with the vertical. Alright. Next, let's try one more problem like this. Okay. So man running on a horizontal road at 8 kilometers per hour finds the rain falling vertically. If he increases his speed to 12 kilometers per hour and finds that the drops are now making an angle of 30 degrees with the vertical, to find the speed and direction of the man with respect to the road. Okay. So let's see if you guys can solve this. All right, let's try this. Okay, am I? Are you guys trying? Please write trying in the chat, please. You guys never do that because then I don't know how long should I be waiting. Okay, speed and direction of rain. 2 under root 3. I doubt that. All right, Pawan is trying. 37, maybe 37, maybe 2 under root 3, maybe. I don't remember. Okay, so yeah, let's wait for a bit. All right, let's wait for Pawan also. Okay, so he says speed is 8 over root 2 and 40.89 degrees. Okay, I don't know. Let's see. Let's see. What does that problem say? It says a man running on a horizontal road with 8 finds the rain falling vertically. Okay. So what I know is the velocity of rain with respect to man should be vertical. Alright. And this would be velocity of rain minus velocity of man. Alright. So from here I can let's start making some triangles. Let's start making some triangles. So imagine again I am not going to write equations. I am just trying to make triangles, vector triangles, and get the answer from there. So let VR vector be. So I'm assuming velocity of rain vector to be like this. All right. So this is VR vector, which is the velocity of rain with respect to ground. All right. So would have you been told that man? Okay, well, man was moving with 8 km per hour. Okay. So okay, I'll have to make this in the opposite direction actually. Yeah, I'll tell you why. So let's say that this is the VR vector. I mean, think about it. This is VR vector, and let's say let VM vector be like this 8. Okay. Now all I know is that velocity of rain as seen by this man is vertical. So what is the so let's draw a minus VM vector. Let's draw a minus Vm vector. So this would be the minus Vm vector. This is minus Vm vector. And this would be the Vm vector, velocity of rain with respect to man. This is what I have been told. Okay. I have been told that. Okay, let's make this with green. All right. So I have been told that when a man moving with velocity 8 looks at the rain appears to be falling vertically. Next, what does it say? Next, it says uh, if he increases his speed to 12, now he finds the drop making an angle of 30 degree with the vertical. So let's do that. I don't know. I don't know exactly. So this was 8. If the velocity of man becomes, if the velocity of man becomes 12, okay, so instead of 8, so this in this triangle, let's write those values. So all I know is that this is 8. Next, if this becomes 12, then you add another vector basically to this 4. Alright. And now, what will be the velocity of rain with respect to man? It would be this. So this would be my second velocity, Vr dash with respect to man vector. And this angle is 30. Okay, I hope you realize what I'm doing here. I hope you realize I assumed the velocity of rain in this direction, added a vector, horizontal vector of 8 in this, then I know my resultant vector is going to be vertical, this is going to be 90. And I know if instead of 8, this was 12. So if this becomes 12, which means I add an additional vector of 4, then the velocity, the resultant velocity would be, or the relative velocity would be like this. And I know this angle as 30. Okay. I hope you guys are fine with the triangles. Now let's see what has been asked. Find the speed and direction of the rain with respect to the road. Okay. So all I need to find is the length of this vector and this angle. So let's call this theta. Now this is very simple. You know this as 4. Okay, now let me show you. Let's assume that this is x. Okay. And let's start marking this. Let's call this O. Let's call this L, M, N. Okay. So now let's look at triangle MNO. So look at triangle MNO. Triangle MNO. What is it that telling me? That is telling me that my tan 30 is 4 over x. Tan of 30 is 4 over x. Agreed? So from here I can say that x equals 4 root 3. Alright. So I got my x. Now let's take a look at the other triangle. Now triangle OML is a right angle triangle where one side is 8 and one side is 4 root 3. Now this is the hypotenuse. I can very easily calculate that. Okay. So similarly in triangle OLM, triangle OLM, what do you know? You know VR square equals x square plus 8 square. So that gives me VR square okay, x square, which would be 16 into 3 plus 64. So that is 48 plus 64. So I'm getting my VR as root of 112. Alright. Yeah. So velocity of rain is root of 112. Okay guys, I don't know what you guys were doing. And now obviously the angle is very easy to find. The theta. You know what is again tan of theta. Tan of theta would be tan of theta. Also tan. Also from this triangle you can see tan theta would be 8 over 4 root 3. So theta would be tan inverse 2 over root 3. That is how you get both the answers. Okay. I hope you guys followed what I did here. Did you follow what I did here? Don't worry about it, Chinmay. I mean, you will always, even if the answer is like this, you will always need to report it as tan inverse of something. They don't expect you to give the actual angles. At least not JEE Advanced. You don't have to find the exact value. Okay, you can just report it as tan inverse 2 over root 3. Okay, so if you guys followed this, see that this is what I wanted to show you. If you started writing equations, then I think this problem can be a little longish. But if you start making triangles and use geometry, then this problem is way shorter. So this is my advice to you. Okay, you are confused why? Just start making triangles. Just go over the solution. Go over the solution. Look what has been told to me, and based on what has been told to me, I started making those triangles. Okay. The advantage of making these triangles is that you realize your calculation is very small. I don't have to write any equations. All I need to do is use geometry once I have made my triangles. Okay. So maybe Chinmay, you can go over this later, and still if you have a problem, then you can maybe ask in the next class. Okay, I'll discuss this. Okay, so for now, let's move ahead. So this is the last part of relative motion, minimum distance and collision problems. Alright, so if two objects A and B are moving in different directions and are at different positions at some instant, then the minimum separation between them during their journey is called the closest distance of approach. So imagine these two are here and one is moving like this and another is moving like this. Now, when they are moving at some point of time, the smallest distance between them becomes this. Alright, you realize right now what is the distance? The distance is this. As they are moving forward, the distance is decreasing, and maybe when they cross, the distance at one point would become minimum, and that is called the closest distance of approach, the minimum distance that these guys come at while moving. Alright, so it will be the perpendicular distance of the position of any one from the line of relative motion of the other. So one way of finding this is that you write the equation for distance. Okay, you write the equation of distance with respect to time. So let's say you find these two sides, and then you somehow write this equation, and then you differentiate this equation with respect to time. The easier method is that you watch the motion of one with respect to another. Alright. So when you are watching the motion of this with respect to this, what happens is it appears to be moving in this direction. Alright. So example here is, let me take this up again. So let's say this one plane is moving like this, another plane is moving like this. Alright, so what I can do is, first thing is that after some time t, I can find the position of this, I can find the position of this after time t. So I can find the value of these coordinates x at t, or let's call this y at t and x at t. So when I found the values of x and y at t, the distance at this time would be this. So d would be x at t whole square plus y at t whole square, the entire thing's root. Okay. So I have found distance as a function of time. Now all I need to do is to find the maxima. I put d of d over dt. So again, a lot of maths involved. This is one method of solving this. However, the other method is a slightly easier method. So imagine this plane is moving like this plane is moving like this. What happens if I see the motion of plane B in the reference frame of plane A? So in the reference frame of plane A, how does B appear? First of all, A starts appearing to be stationary. So A becomes stationary and B gains another velocity minus A. So this is minus VA, this was VB. So the net velocity of B appears to be along this direction. So let's see from this reference frame what it appears. It appears as if A stopped at his position and B will be moving along this straight line. And now that B is moving along this straight line, you know what is the closest distance between them. Closest distance between a point and a straight line is always the perpendicular distance. This would be the closest distance. So you can apply this approach to find the closest distances. Okay, you watch the motion of one from the reference frame of the other, draw this line, and then find the perpendicular distance. Yes, give minus times velocity of A to both A and B. All right. Okay. Similarly, assume that if they are moving like this, what happens? What is the condition that for which they should collide? If you see the motion of one in the reference frame of the other, if you see here the motion of B in the reference frame of A, so it would appear as this and minus of this. So this is VB vector and this is minus VA vector. And if this resultant is along the line joining them, then they will collide. Alright. So please remember the condition for collision between two objects is that their resultant velocity or the relative velocity of one with respect to the other should be along the straight line joining them. Very, very important result you should remember. Alright, so I am writing this here. Let me write it with a dark pen because this is a very important result which you use a lot. So condition for collision is that the relative velocity of one with respect to other should be along the line joining both. Now you could have calculated the relative velocity of any one of them with respect to the other. As long as that is along the line joining both, they will collide. Okay, so please remember this. This is very, very, very important. And for this, mathematically, your equation becomes like this. Okay, this is what mathematically your equation becomes. Okay, so this. All you're doing is you're saying that this component and this component should cancel each other out. Okay, and of course, once you have this, the time of collisions would be L over V of approach. V of approach is the relative velocity along the line joining them. All right. So that is how you solve this kind of problems. So why don't we practice one problem quickly? A car and a bike are moving along two perpendicular roads with constant speeds of 17 and 10 meter per second. If their initial positions are as shown, you to find the minimum separation between the two during their journey. Okay. All right, let's try this. What would be the minimum separation between the two? Why don't we try this? Okay. So I hope you guys are trying this. So how do you do this? You see the motion of one with the reference in the reference frame of the other. Okay. All right. So I hope the diagram is clear to you. You have a car and a bike which are moving along two perpendicular roads as shown. All right, so this is your car. It is moving like this. This is your bike. The bike is moving like this. The speed of the car is 17 meter per second. So this is 17 meter per second. Car is moving with 17 meter per second. The bike is moving with 10 meter per second. And they are initially at t equals 0. The bike was 20 meter from the cross section. The car was 17 meter from the cross section. Now when they cross, they will cross like this. Alright, so this is what they will do. You'd find the minimum distance between them during their entire journey. Okay. Okay, till the time you're trying, Pawan, I'm just making my own diagrams. All right. So Pawan says 4 meters. I really doubt that, Pawan. Let's see. So this is what the bike will see the car to be doing. Okay. So I've made this. So bike sees the car to be doing this. So car seems to have a velocity in y as 17 and a velocity of x as minus 10, which is minus 90 velocity of the bike. So car ends up moving like this. Now all I need to do is I need to find this minimum, b minimum. So for this, I already know what this distance is. What is this? This is when the car is right in front of the bike. So let's go back to the figure. What happens after 1 second? Imagine after 1 second, the bike is here, the car is here. Alright, at t equals 1 second. So what is the distance between the car and the bike? It would be 10 meters. Right? This is what this is. If you look at this, this would be 10 meters. Why? This is when the car would appear right in front of the bike. Okay, it will be going down, and this is when it crosses the road on which the bike is traveling. Alright, so I already know this length, which is 10. Now all I need to know is if I can find out this angle theta, then I know this angle theta. Alright, then from this triangle I can easily find out d minimum. Now finding this theta is very easy. This theta is also this theta. Now from parallelogram law, you know the resultant is this. Then what is tan of this theta? Tan of this theta is, I know tan of theta. Tan theta equals 17 over 10. So 1.7. And I've been told that take 1.7 is as roughly root 3. So that means theta is 60 degrees. Now once I know theta is 60, let's try this. Alright, so I've marked the perpendicular point as P, the position of car as C dash. So now look, let's take a look at the triangle C dash BP. So let's look at triangle C dash BP. What do you see in that? You see that okay, sine theta is d minimum over 10. Alright. Yeah, perpendicular upon hypotenuse. So from here you will get your d minimum as 10 times sine of 60 being root 3 over 2. Alright, so 5 root 3. That is the answer. So obviously 5 root 3 is going to be bigger than 4 psi. So see where you made your mistake. This is the answer. 5 root 3 meters. Okay. It's very, very simple. See, once you draw all these triangles, then the calculation part is nothing. Otherwise, what you would have done was write the equations. See, let me tell you the second method also. The second method would have been after time t, you would have said this car comes here, so this is 17 minus 17t. Similarly, this is 20 minus 10t. Alright, the distance would have been this square plus this square's root, and then you would have differentiated the distance with respect to time. A very, very long method. This is a way shorter method. Just look at the motion of one with respect to another. Make triangles, use properties of triangles to find the unknowns. Okay. Okay, so the last problem that I wanted to discuss about relative motion is this. So three particles A, B and C are situated on the vertices of an equilateral triangle of side R. At t equals 0, particle A starts heads towards B. After this session, I'll try a lot of problems so that I can avoid making mistakes. Yes, of course, practice is needed. Pawan, a lot of practice is always needed. Getting your concepts right is one thing, but you have to have practice as well. Alright. Okay, so this problem says, so I'm straight away going to discuss the solution because I'm getting late and I have another session planned at 6. Okay, so yeah, Pawan, the session that we were trying to have yesterday, the biggest confusions about and the biggest misconceptions about Newton's laws, we will have that today, okay, at 6. So you guys can join me for that session also at 6. We will discuss what are some of the biggest misconceptions that people have about Newton's laws. And trust me, nobody is making those correct. I mean, people are using wrong equations and nobody's telling them not to. So that is why I decided to take up a session wherein we will discuss those. Okay. So here you've been told that three people are standing at the vertices of a triangle. Alright. Okay, this is particles. So particle A starts heading towards B, B starts heading towards C, and C starts heading towards V, A with constant speed V. To find the time of their meeting. So first of all, let's see how they will meet. So at t equals 0, let's assume A is here. Okay. Yeah. Okay, so one more thing. Unfortunately, my pencil battery has died. So why don't we discuss this problem tomorrow? This is the last problem that I had in mind in any case. So let's wrap it up today for the right here so that I have some time also to prep for the next one. Alright, so we will start the discussion tomorrow, day after tomorrow about Newton's laws. Okay, and yes, we will discuss this problem before we start that. Okay, so let's wrap it up for today so that I can come back, so that I can charge this pencil before I have to come back live again. Okay. So that is it from my side for today. This one problem we would want to discuss again. In any case, I wanted to take my time in discussing this problem, so it's good that now we have an opportunity to start the next class with this discussion. Okay. So before I leave you, let me remind you that you can get your Unacademy subscriptions following these very, very simple steps. Go to the plus section, select your goal as IIT JEE and click the get subscription button. And when you're getting your subscriptions, so please note that these subscriptions are already very, very affordable, but they can get even more affordable if you use my code RDLive while getting your subscriptions. So remember to use the code RDLive in getting your subscriptions and get access to all the wonderful features of the Unacademy Plus and also get a 10% additional discount. Now, if you like today's video, then please press the like button and share it with your friends. Don't forget to press the bell icon, and the PDF notes of the slides used would be available in maybe a couple of days or so. So you can come back in 2-3 days and check that out in the description box. Now, don't forget to join us on the Telegram app for the using the link shown above, so that you get notifications of all the sessions and lectures being conducted on the JEE English app, JEE English channel. Now, before I leave you, let me remind you one more time, my code is RDLive. So if you like my lectures, if you want to enroll in my courses on the Unacademy app, then you can get your subscriptions using this code RDLive and enjoy an additional 10% off as well. All right, so I'll give you see you guys next day after tomorrow. That is on Wednesday at the same time, 4 o'clock. All right, till then, you guys can take care. Bye bye.